it automatically stops, and then I can close the tool. What I can do now is to calculate the section, and here you can see that it's automatically defined its centre of gravity, the S point, and the shear centre, which is the M point. However, this is taking into account my boundary being completely filled and being a solid section. So the next thing I need to do is to enter the opening within my section, and I'm going to do this with the opening tool. Again, I have my concrete material selected. Now I'm just going to right click on the drawing and select point in area, and there very simply it selects my lines for me, and there is my opening formed. So if I calculate the section again, then you will see that my centre of gravity and my shear middle automatically modify. Here the shear point is following the centre of gravity point. If I double click on that, then here I can see some properties for the shear cut, and the shear cut is used in the calculation for calculating the shear within a section, and you can specify these wherever you need the shear output. So this shear cut is linked to the centre of gravity. You can deselect that if you want to. What I'm going to do here is just to specify a second shear cut. The shear cut is within the concrete material and the reinforcement material. I'm just going to specify an unlimited cut, and to output the mid, start and end points, I'm just going to click on my drawing and then select a cut point. Right click and enter, and the tool closes itself. The next thing I'll do is to create some reinforcement, and I can do this by using the linear reinforcement tool. I'm going to select that from the C tab this time, linear reinforcement. Now it gives me a warning message. I first need to create at least one reinforcement layer in the general properties box, and here it allows me to open that directly. If you remember, when I showed you this at the beginning, it already had 2 layers specified and I gave it a third. However, because I've calculated it before those have been used, they've automatically been deleted. So now I'm just going to create those very quickly again and click on OK. And now I have the opportunity to specify my reinforcement. So here for the name, it's given it a number. I can also give that a proper name. So if I specify top, and I use layer number 1, here my 3 layers are available for use. It gives me the option to be able to use this reinforcement with the torsion calculation. However, I don't want the linear reinforcement here to be used in the torsion calculation, so I'm going to leave that as passive. I could set that to active if I did want it to be. Here I can specify a reinforcement bar diameter, and here I can specify a value for my absolute reinforcement, and that is my minimum value of reinforcement. So if I click on my small calculation box here it allows me to also change the bar diameter again. I can specify the number of bars that I would like to see per meter, or I can specify a spacing for those bars. So here I'm going to specify 150mm spacing, 0.15 meter. Now click OK. If you were wishing to assign a maximum steel area, then you could use the max relative reinforcement, and this would be useful in such cases as where you wanted to analyze an existing beam, for example. Here at the bottom you have the opportunity to specify a construction stage. I'll go over that a little bit later on. So now that my information is set, I'm just going to click once on the drawing and then draw in my lines on top of my AutoCAD geometry. So now I've drawn my first line. If I pressed enter at this point or close the tool, then the next time I opened it I would have to re-specify my information. However, I have several bars that I want to specify now, so a shortcut to how to do this without re-entering the information is simply to draw in all of your lines. Each line that's placed is a separate entity. And my last one there, so I'll click on enter. And then all I need to do is to select the reinforcement lines that I don't need and simply delete them. So I'll repeat the process again, and this time I'll specify some bars for the base of the section. Now I'll change to the second layer. I'm also going to leave it passive for torsion, and then just specify my bar spacing again. And I'm going to repeat my input there for the bars. And then delete the ones that I don't require. In this way you can continue around assigning your different bars to different layers. When your calculation is finished, then you can view the values for the reinforcement according to each layer. To be able to view the section properties of the section that you've drawn, you can very simply press the F2 button. Now the window's appeared behind my SOFiPLUS window there. I'm just going to minimize that. And here is the text window that appears. I've made a mistake there, I haven't calculated it first. So I'm just going to calculate the section and press F2 again. Where's it gone? Here it is. And if I scroll up a little, here you can see that it's done a calculation of the section, and here it gives you all of your section properties. You can view these again later on when you have finally calculated your section, and you can open that with the results viewer Ursula, or within the other results viewer, well the section viewer, which is called graphics. I'll show you those very shortly. Just one more quick point to note. When you're building larger cross-sections such as these, then it's very simple to be able to use the construction stage manager. However, I won't attempt to show you that in this short time on this section. I'll show you on a section later on. So now I'm going to close that section. I'm going to save it and calculate it. And then what I'm going to do is to assign that very quickly to my structural line that's already there. So I'll use the Modify Structural Line tool. Click on my object and right click. And then my section number 3 appears there. I'll click OK to that. And then export. And then view in the animator. So here you can see my section has now been applied to my structural line. If you had, for example, an asymmetric section and it was appearing in the wrong orientation on your line, then what you can use in the Structural Elements tab is the Align Elements tool. And with this you can select your line, then you right click, and here you can set your X direction. There are a number of other options for orientation here as well. If you'd like to see a little more about that, I'd recommend viewing part 3. Okay, so back to the Assist tab and the cross sections. I'm now going to create a composite steel section using some UPE sections. So now I'm going to right click on cross sections and click on New Standard Section. This time I'm going to use a rolled steel and click OK. So in here I have my steel material already selected. I'm going to choose a UPE section. It's 300 deep. And what I'm going to do here is to mirror that, and I'm going to choose to mirror it on the Z axis, which you can see here. And my reference point I'm going to choose as top right, and here it's allowed me to create a mirrored section. There are other options here to create a thin-walled section, but here I'm going to stay with a solid section. It also calculates the section properties at the bottom for you to view. So I'm going to click OK on that and then open it to view. Now again, as in the first section, you can't directly modify this section, however you can do so. So I'm going to close that again. I'm going to right click on the section and select Explode and then open it again. And then here what I can do is I can select some elements. I could perhaps move those. And then when I recalculate, it tells me where my updated central gravity and shear points are. It also gives me a warning that these are not connected for shear anymore. What I can do now is I can also insert some new steel profiles. So again in here I'm just going to choose the same section, a 300, a reference point at the top left this time, and click OK, and then I simply select a point where I enter my section, and there it appears. And if I wanted to, I could then move my other section back over to be joined with it. When I calculate again this time, it tells me that there's no warning this time about being connected for shear. When a section is auto-generated in this way, what the program has done is it's entered some shear points automatically. You can also do this manually by using the stress point, I beg your pardon, they're stress points, not shear points, by selecting the stress point tool over here. And here I can put these in at some other locations where I might like to take a result from. So here it's given it an automatic name, and for the material here it's specified it as concrete. In this case I need to redefine that as the steel. It will give me an error if I don't do this. So then all I need to do is to click back on my drawing and select a point where I'd like to take my result from. So now I'm going to close that and take you on to the final section. It just takes a couple of moments to calculate that section. And this time I'm going to create a thin-walled section. Now in here I'm going to create a composite steel and concrete section. So for example, if I had a steel frame which was to be erected first and then a concrete slab to be placed on top,